Good day, students and viewers. My name is Abdulaziz Idris. I am your regular Math 103 tutor. In today's video, we are going to study trigonometry and coordinate geometry, and this material is provided by Dr. A.T. Imam from Ahmadu Bello University, Zaria Department of Mathematics. And in today's first lecture, being the first video lecture, we are going to give a recap of the course outline. We are going to give the course outline of what we are going to cover in this course throughout. We are going to cover part 1, which has to do with trigonometrical ratios, where we are going to look at the plane angles, measurement of angles, trigonometric ratios of angle, sign of trigonometric functions, reference angle, trigonometric ratios of spatial angles, and then cofunction relations. In part 2, we are going to study trigonometric identities, where we are going to look at basic trigonometric identities, addition formulas, double angle formulas, half angle formulas, factor formulas, solutions of trigonometric equations, height and distances, sine rule and cosine rule. Part 3 is going to talk about straight lines, rectangular coordinate system, distances between 2 points, and then equation of straight lines, midpoint of a line segment, parallel and perpendicular lines, distances from a midpoint of a line. In the last part, which is part 4, we're going to cover circles. That's the coordinate geometry part. And in the circle, we are going to look at general equation of circles, and then tangent to circles, point of intersection of lines with circles, and then we are going to look at touching circles, and then intersecting circles, and the orthogonal circles, then radical axis of two circles. Part 1. To start with the lecture, we are going to start with trigonometric ratios. And in the trigonometric ratios, which is part 1, we are going to cover plane angles. An angle is just a point where two lines meet. So exempting the straight line angle, which of course is an angle consisting of either two or more angles in general. But if we talk about trigonometry, most at times we are going to talk about the geometry of triangles, actually, and which has to do with trigonometric functions. Definitely, if you look at the diagram closely, look at this diagram, you see that if OX is a reference line, sorry, OA is a reference line, and then you look at the angle which the line OP makes with the positive x-axis, which is the OA, and then also look at another line that makes an angle with the positive x-axis, but in clockwise direction. So here the angle is positive if it is in the anti-clockwise direction. That's the angle OP. The line OP makes an angle with the line OA. That is a positive x-axis. So that angle that makes with an arrow we can see here is a positive angle because it is in anti-clockwise direction. And the angle which the line OQ makes with the line OA is in the clockwise direction, and that is a negative angle. Sorry about the typo here, is negative angle. So you see OA is called the initial side, while OP is called the terminal side. And the origin is called the vertex. That's the point where the two lines meet. If you take the line OA and OP, so the vertex is O. Taking the line OA and then OQ, the vertex is still O. That's where it serves as the meeting point of the two lines. So angles are usually denoted in Greek letters, usually the lowercase letters. See, alpha, beta, theta, psi, phi, and so on. An angle is said to be in its standard position if its vertex is at the origin and its initial side is along the positive x-axis. So like the angle here the angle here the angle here is in is in start in is it's in standard position. It is in its standard position because uh, this is the positive x-axis. So whenever you have an angle like this, so this angle is called is said to be in its standard position because its initial side is the positive x-axis. But talking about this angle now, the angle here is not in its standard position because this is the negative x-axis. Get another angle here. The angle is not in its standard position because its initial line is not on the positive x-axis. So so going by that, recall, if you can remember, that the xy plane is partitioned into four parts, and the four parts are equal. And we call this, each part is called a quadrant. For example, look at the diagram here. So we divided the xy plane exactly into four parts. So these parts are called quadrant. So the first part here is called the first quadrant, here is called the second quadrant, here is called the third quadrant, and here is the fourth quadrant. And these quadrants are going to be studied in terms of the sign of a trigonometric function, where it falls. It depends on where the trigonometric function falls, and that is where to give it a sign. An angle in standard position is said to lie on the quadrant where its terminal side lie. So, for example, whenever you have an angle, if the terminal side is ending in a particular quadrant, then that angle is lying in that quadrant. For example, look at the example A here. So this line, the terminal side is lying on the first quadrant here. So this angle is in the first quadrant because the terminal line is in the first quadrant. Look at also the second angle B. So the angle here is in anti-clockwise direction, but the terminal is in the third quadrant. So the angle is said to be in the third quadrant. Similarly, two angles with the same initial and terminal sides but have different signs. They have different signs, meaning they have one is positive and the other is negative. These two angles are called coterminal angles. An example here is provided on the second part of the diagram. I think this is the second part of the diagram where you have the A part. You see, I mean, on the second part of the diagram, the B part, you see that the initial side of this, the initial line is on the x-axis. Here is the initial line, this angle, and they have the same terminal line, which is this line. See, but the other theta is in anti-clockwise direction, meaning theta is positive. But phi is in clockwise direction, and so it is negative. So this phi is negative, while theta is positive, and they have the same initial and the same terminal point, so they are called coterminal angles. Now we go to the measurement of angles. We measure angles usually in degrees, and we denote when we measure an angle by a degree, we use a small circle on top of the number to show that the angle we measured, that the measurement is in degrees. So now, whenever you are measuring an angle in radian measure or in degree measure, the two measurements are different. You either convert to a radian measure or you convert to an angle in degree. Mostly when you are, generally, if you are measuring an angle, you are measuring it in terms of degrees. And if you are measuring an angle in terms of degrees, you are measuring it out of 360. That is complete revolution. And if you are measuring an angle in radian, you are measuring in 2 pi. That is the rotation. The rotation of the complete revolution is in 2 pi. And therefore, it has to be in 180. And so, a degree is then defined as the measure of angle theta, which inscribed an arc of length 1 over 100 and 360 degrees. A degree is divided into minutes and minutes into seconds. So you can divide a degree into minutes and then you divide minutes into seconds. So a degree, a minute is denoted by a dash or a prime on top. That's a comma on top to show that that number is representing a minute in terms of an angle. And a minute is 1 out of 360 degree. And a second is denoted by a number with inverted comma at the top, and is 1 out of 300 out of 60 of a minute, and that is 1 out of 60 times 1 out of 60 times 60 of a degree, which is equals to 100, which is equals to 1 over 3,600 of a degree. Thus, we look at a degree is equivalent to 60 minutes, and 1 minute is equivalent to 60 seconds. And therefore, 60 seconds times 60 will give you 1 minute. And we have an example. We are asked to express each of the following in degrees, minutes, and seconds. Number 1. So in terms of the solution here, we convert the whole number, we allow the whole number to be in degrees, and then the decimal part, we convert them to minutes and seconds respectively in such a way that in the final solution, there will be no decimal point. So let's go by the first example here, A. So we have 63.7 degrees. And then 63 degrees is a whole number. So we take the decimal point, which is equals to 0.7 degrees, and then convert it to minute. And to convert a degree to minute, we multiply by 60. If you multiply this by 60, you are going to get 63 degrees and then plus 42 minutes. That is the product of 0.7 and 60 is going to give you 42. So since you have multiplied a degree by 60, it's now a minute, and then you put the minute symbol, and then you have 63 degrees, 42 seconds. We also take the number B part, or B is similar. Let's take the number C part. because C is a different scenario. We look at the C part, which says that 58.37 to be converted to an angle comprising of degree, minutes, and seconds. Now, 58 is a whole number as a degree, so we leave it the way it is. So we have plus 0.37. So we convert 0.37 to an angle in minute. And to do that, we have to multiply it by 60, as we can see. If you multiply it by 60, you are going to get 22.2 minutes. Now, you have a decimal point in the minute. So you still go ahead and convert the decimal part of the minute to second. So you have 22 minutes plus 0.2 minutes. And then to convert 0.2 minutes to an angle in second, you multiply again by 60. So you have 58 degrees plus 22 minutes, and then plus the decimal part of the minute, which is 0.2 times 60, which if you hit your calculator, you get 12 seconds. So the answer is finally 58 degrees, 22 minutes, and then 12 seconds. You see, there are no decimal point in the final answer. So as you see, the D and E part are done in a similar fashion. Now, let us look at